Hello everyone, welcome to Day 4 of LRI Engineering's Emergency Preparedness Week training series, The Psychology of Preparedness, Why We Prepare and Practice for the Worst and How Doing so affects our ability and our brain to handle emergencies and be resilient in the aftermath. It is important to understand how we and our bodies respond to a threat in order to understand how and why we prepare for them. The stress response begins in the brain. When we confront an oncoming car or other danger, the eyes or ears, or both, send the information to the amygdala, an area of the brain that contributes to emotional processing. The amygdala interprets the images and sounds. When it perceives danger, it instantly sends a distress signal to the hypothalamus. This area of the brain functions like a command center, communicating with the rest of the body through the nervous system. The autonomic nervous system, which regulates automatic body functions such as our heartbeat and breathing, has a direct role in physical response to stress and is divided into the sympathetic nervous system and the parasympathetic nervous system. When the body is stressed, it produces hormones that activate the sympathetic nervous system, which contributes to what is known as the fight or flight response. The physiological changes that occur during the fight or flight response are activated in order to give the body increased strength and speed in anticipation of fighting or running. It is important to understand that the fight or flight response is a natural and expected response to a threat that prepares your body to either stay and deal with a threat or to run away to safety, which is also to say that it should not be confused with panic. For example, attempting to put out a fire, fight, or leaving a burning building, flight, are both rational responses to the fire, whereas panic is defined as an irrational response. Here is where training and preparedness comes in. Using the example of a fire again, should you decide to attempt to put the fire out but not know how to use a fire extinguisher, or decide to leave the building but not know where the emergency exit is, you are facing the threat all over again, now with less time and at a risk of panicking. However, both these rational responses can in fact incite panic if lack of training results in ineffective action and less time to evacuate during an emergency. Training provides you with both knowing what to do and how to do it, allowing you to make smart decisions well under stress. Once you are aware of what to do, it is also important to practice it. Throughout our lives, we learn to do things. Some things, small things like tying our laces, or more complicated things like driving a car, seem difficult or intimidating at first. But the more times we do them, the easier they got. This is the same principle we need to apply to our emergency preparedness. Similarly, as we do things more often, we may find better ways to do them that suit the situation or are more efficient. Are you an over, under, and through, or bunny ears lace tire? Or did you decide Velcro or slip-ons were better? The more you do something, the more confident you become. I bet you don't think twice about how you tie your shoes. When you navigate a difficult situation confidently, the experience is perceived by the brain as positive, and that builds resilience. As the presentation began with how our brains react to a threat, to conclude, let's look at how your brain is affected by practicing. Practice translates to real physical changes to the structures within your body, ultimately making you more efficient. Here's how. You have two main types of matter in your brain. The first is gray matter, which processes information and directs signals and sensory stimuli to nerve cells, neurons. Then there is white matter, which is a combination of nerve fibers, axons, and fatty tissue. Axons are simply long, thin projections of neurons. Their job is to conduct electrical impulses away from the main body of the neuron. If you think of axons as electrical wire in the way they function, electrical wire usually has insulation around it to prevent the loss of energy and keep it moving efficiently along the proper path. Axons are exactly the same. They have a natural insulating sheath known as myelin. Every time you practice and repeat a physical motion, you build up layers of myelin around your axons, improving their insulation. Scientists believe this extra insulation makes such a difference in the axon function that it essentially creates a sort of superhighway for the electrical signals traveling through your body. By practicing and building this extra insulation, you increase the speed at which the brain and your muscles are communicating, improving how fast recall, command, and response take place. pretty neat. I hope you have enjoyed learning about how your brain works in an emergency and how practicing helps you be prepared. This online training has been produced and presented by LRI Engineering, Inc. LRI is a Canadian professional engineering firm specializing in emergency planning, fire protection engineering, building and fire code consulting, and accessibility consulting services. For more information about LRI and how we can help you, please visit our website, follow us on social media, or call us today. Thank you for watching. Stay safe.